Hi guys, so we are back on this portion. I will continue the one that we just left earlier. So that let me share screen, and that is this one here. Yes. All right. So we were talking about this oogenesis, and we know that this oogonia are the stem cell, and during the fetus development, they uh, by about start at about 5 weeks gestational age, they start to produce the primary oocyte, and when they produce the primary oocyte, they save it in a a suite, just one single oocyte surrounded by a single layer of the follicular cells. So this whole thing is called a follicle. So that's a term right here, follicle. And the most fundamental or most basic, the original follicle is like this one here. So this is called the uh, primordial follicle. And they will stay at this status for many, many years, uh, since right after they were produced, and until the baby is delivered, has a birth, is delivered, and they live for many, many years until puberty. So they is called a meiotic arrest. Meiotic arrest is arrest at what? At the prophase stage. So we know like that's why we in the very beginning we spend almost a week talking about cellular physiology, and the portion is that we look into the cell division. In the meiosis, there is the first meiosis and the second meiosis, the first stage, second stage, and in the cell division we have the IP. Uh, sorry, interface, prophase, IPMAT, right? So interface, prophase is the first phase of this meiosis. And so cell already being duplicated. Here we have 2n times 2. So this is the diploid 2n, and it has duplication further. So we have 2n times 2, but everything is at rest, readily saved in here in this environment. This is called the primary oocyte living in a primordial follicle. So that's that. And so they will stay here for many years. If the puberty is about, say, 14, right? 14 years old. So this is months plus 14 years old. So several years before they start to kind of awake and develop again. So that's that. All right. So this is the one that in that before birth. So here is before birth, and this everything happens before birth, and very interesting that after birth and before puberty, nothing changed, nothing happens with this oocytes. So the before birth, this oogonia will mitotic divided into many primary oocytes. And then this primary oocyte living in a primordial follicle. So oocyte give rise to the, oogonia give rise to the oocytes. These are the primary oocytes. And so then stop in prophase 1. So they have 46 times 2 to be more accurate, 46 times 2. And they remain the state until puberty. They don't live just by itself. They are very carefully treated, very carefully surrounded by these cells, follicular cells. And so following this, we will start not just the uh, oogenesis, the oocyte development, but also the follicular development is called the folliculogenesis. So that's that. So when the time is right, meaning that when the hormone is high enough, what hormone is very much like in the male, you know, we would the very important hormone from the anterior pituitary gland are two major hormones. One is the follicular stimulating hormone (FSH), and the other one is the luteinizing hormone (LH). Now, when the hormone continually secretes along with the development of the body, when this hormone is high enough, they start to wake up these follicles, and that's the name coming from the follicle stimulating hormone. So the very first identified function of this hormone is to stimulate the follicle, and then this follicle start to develop. So very much like this one here. So this is at birth, right? Before birth, and this number actually reached to the maxima at about 20-week gestational age, and then they gradually decrease. So this follicle remain, and then at birth it's like about 1 to 2 million in the females ovaries. And then is let me go back to this one here. So that's right here. So that number, this is number of oocytes, number of primary oocyte, meaning the number of the primordial follicle. They reach to the maxima at about 20-week gestational age, and at birth is about 1 to 2 million. So that is the amount inside of the ovaries. And then they will remain, even though the number decrease, there are some get lost, but the shape, the status of each one remain the same, remain like this one here. They remain it until, so that's a very long arrest until the puberty, when the follicular stimulating hormone and luteinizing hormone reach to a high enough level, and then this will also stimulate, and then they will stimulate the follicle development. And so what follicle does is that, so along this process is called the folliculogenesis. So oocytes is here. Oocytes remain, is continue growing, of course, but what the majority change is in the entire follicle. So you can see that follicular cells will get, if the follicle become bigger, we will have more follicular cells, and then there will be a fluid cavity inside of this follicle, and then this is by the time that every month we have a group of the follicle go through this folliculogenesis, and then we will but a group, meaning about a couple thousands, go through this every month. But in the end, we will have only one reaching to the most matured status. The other will get degenerated. So every month we have only one get ovulation, and it's called ovulation. And so that is the process of the folliculogenesis. So good quiz question is that, when does the folliculogenesis started in the lifetime of a female? So the answer should be starting at about the age of the puberty, not the birth, not the fetus, but puberty. What's time the meiotic arrest happens? You know, it's like before puberty. Anytime like at birth to puberty is around that. So that's that. And the ovulation is that now the oogenesis and folliculogenesis will continue after the ovulation. Ovulation is a movement of this follicle from the ovary into the uterine tubule, or yeah, for fallopian tubule, and they will fall in there, fall into the fallopian tubule. So that's right here, fallopian tubule, fallopian tube, and then it will be ready for fertilization. If the sperm is there, one will reach, and it will start to develop into the blastocytes and then the embryo. But if there's no fertilization, then this will be degenerated, and then we will have the menstruals. So that's that. So this one just showing you that the primary oocytes will, after the puberty, these primary oocyte will continue its meiosis stage 1, and it will generate the 2 daughter cells in the stage 1, and then another 2 daughter cells, total 4, right? But in the first meiosis, only one will remain, and the other one will form the polar body. You might know that this whole thing remains staying in the follicle, so they are not like indifferent, because whole thing is in the follicle. So this first polar body remain in the follicle. So you can the idea is that this primary oocytes then divided after the puberty, and then these ones remain. This one will, or 2 of them will stay in the follicle, and these 2 will go into the ovulation, and then ovulation happens in the ovulation, and this one, the second one, right? The second one will conduct the second stage meiosis, and the second stage meiosis is the separation of the sister chromatids. The first stage is to separate the homologous chromosomes. The second stage is to separate, right here, separate the sister chromatids. And so they will reach to this state until the egg coming, the sperm coming in. If the sperm enter, they will complete this. They will stay in the metaphase until fertilization. If there is no fertilization, then it will go. They will get degenerated, disintegrated, and released as the menstruation. If there is the fertilization, then they will complete the metaphase, and the other one will form the polar body, the second polar body, and this one will mate with this sperm and to form a, diploid fertilized egg. Yeah. So that's that. So that's a fertilization. They will stay as the metaphase only until the sperm coming in. They will form this anaphase, and then finish that anaphase. One of that daughter cell will become a second polar body, and the other one will merge with this sperm and become a diploid cell. And you need to know that all this will remain inside of this follicle. So that's that. So this one summarizes it. The primary oocytes will stay in an arrest at the prophase. So during that prophase, we have 2n times 2, and until puberty. And at the stage of puberty, the follicular stimulating hormone will stimulate the development of the follicle, and that's a process called the folliculogenesis. And that will also trigger the continuous of the oocyte meiosis. So the oocyte will complete the meiosis stage, first stage, right before one day, the day before the ovulation. And then this will go into the fallopian tube. Then they will see if there is sperm. If there is sperm causing the fertilization, they complete this meiosis, second stage, and then it's fertilized. If not, then menstruation exists. So this is the figure showing you the entire oogenesis go along with the folliculogenesis. So this one is the folliculogenesis. This one is oogenesis. It's not like two different cells. It's these cells are inside. It's difficult to see here, but if we kind of get into the room and see what's going on inside of this follicle, and that's right here. So before oogonia is not living in the follicle, so they continue to divide it to produce a lot of the primary oocyte, and each primary oocyte living in the follicle. So first is the division stage. Then we have the growth stage. In the growth stage, they grow inside of this follicle, and to the prophase. Prophase 1 is stop until puberty, and at the time of puberty, the prophase continue. Only each month, about a couple thousand get developed. So that prophase 2n times 2 will be divided to 2n and 2n, and the 2n will, one is the first polar body, and the other one is the second oocyte. And then, and in the same time that the follicle continue to develop, so this is the folliculogenesis until the ovulation. Once it's ovulated, it completes its first stage of the meiosis. Then this second oocyte will go through the second stage of the meiosis. Now we have the sister chromatids will be divided, and it will reach to a metaphase, get arrested in the metaphase 2. And the signal is the sperm. If sperm coming in, they complete this metaphase 2 to the anaphase 2, and to become separate cells. And one of that daughter cells will combine with the sperm to form a 2n diploid fertilized egg. The other one is the second polar body. So that's that. If not, then it will be disintegrated and conduct the menstruation. So that's that. Now let's get some summary about what we have with the spermatogenesis and the oogenesis. So spermatogenesis, we have this spermatogonia, the diploid stem cell. This cell remain available throughout the entire life. When they divide it, part of it will be used to replenish this stem cell. The other part, health, will develop into the primary spermatocyte, and then this primary will be divided into, will conduct the meiosis division to produce 4 sperm cells. So that, and this process happens continuously throughout the life. As for the oogenesis, basically there are some similarity but some difference. One first difference is that each primary oocytes only produce 1 egg. In contrast, one primary spermatocytes produce 4 sperms. The second difference is that in the sperm in the male, these spermatogonium remain available throughout life. In female, oogonium only available in the early ages of the early gestational ages. So we don't have oogonium in the female after birth. So that's another difference. Now with this case that we have the primary oocytes, and each primary oocytes stay inside of this follicle, they will get divided, they will stay arrested until puberty. Only when it's only after puberty, they continue to get divided. This division happens a day before the ovulation, and after ovulation, one will become a polar body. They can be further divided, but this basically considered that it's not functional. And the other one take all the important nutrients, organelles. This will further get divided, and this one will continue its meiosis. They will reach to a metaphase and waiting for the sperm. If sperm coming in, it will get divided. One will mate with the sperm to form the fertilized egg, or called the ovum, fertilized ovum, and the other one become the second polar body. So I want to use these last three slides to talk about something like an earlier portion that we didn't talk about earlier, was that what is the source of the oogonium and the spermatogonium. So what's the source of that? So these are stem cell, but you know, the zygotes, this fertilized egg, start to develop from the egg, and so the sexual difference. So this spermatogonium and, did I record? Yeah, I do. Good. So this spermatogonium and the oogonium is different depending on the sex. So what's the common one? What's the source of it? The source is the primordial germ cell. So the idea is that, let me use this one very easily to understand. So I modified this figure from a review article talking about the germline development. So here we have the zygote, right? So here is the diploid, the very first one. Then this cell will continue to be divided. It will have the inner cell mass, and then it will form this the early stage, the 3 like germline. Sorry. So to have this ectoderm, mesoderm, and And then from here, we have this early germ cell. Now this germ cell will start to travel into the gonads. So along this development, this primordial germ cell will travel into the gonads, and only until these gonads developed into the ovary or testis, this differentiation, the ovary versus testis, will then induce this primary germ cells to become either the oogonium or the spermatogonium. So that's how they get started. They need to migrate into the gonads, and the gonads, the established gonads, induce them to become the committed germ cell. It's either the oogonia or spermatogonia. So this is summary here. So the spermatogonia and the oogonia are formed by the mitosis from the primordial germ cell, PGC. And during the even earlier fetus development, then this this primordial germ cell will then travel to, they are arise from the proximal epibreast under the influence of the extra embryonic signal. So it basically that's the development process of these embryonic cells. And so this is part of then the precursor primordial germ cells then travel, they migrate into the genital ridge. This is the region that's going to be developed into the gonads, but not yet the undifferentiated gonads. So this is not fully differentiated. Later we will learn that this undifferentiated gonads including two different tubule, and only when there is specific Y chromosome, then genes in the Y chromosome, then these gonads will become a testis. Otherwise, it will develop into the ovaries. So by the age of 4 to 5 weeks, these gonads then differentiate into the testes and the ovaries, given the exist of or presence of this special X chromosome, Y chromosome. Then this by the influence of the testes of ovaries, then the primordial germ cells will then differentiate into the spermatogonia or oogonia, respectively. So that's that. All right, and here is the picture showing you that these primordial germ cells is not differentiate to different germs in male or female yet, only until the gonads develop into the ovary versus the testis based on the Y, basically Y chromosome. Then it will this primordial germ cell will then develop into the spermatogonia versus the oogonia. Oogonia, yeah. So that's that. So this is the developmental cycles of the germ cell. Germ cell or germline is the collection of these cells that transmit this sex information, and it's also very important to transmit to conduct the duplication from one generation to next generation, because other somatic cells doesn't have the capability to produce another organism. So that's that. All right. So I finish it, and let me know if you have any questions.